When adding or subtracting polynomials, we often need to combine like terms. So let's go over what like terms are. Like terms are terms whose variable and their exponents are the exact same. The coefficients can be different. So let's go over this left side. We have 4x squared y, and x squared y divided by 5. As you can see, x squared y, and x squared y are all in these terms. Because of that, it has a like term of x squared times y. As you can see, there's exactly two x's that are multiplied together, multiplied by a y. In this case, their variable and their exponents are the exact same. There's two x's here, and there's one y. Now, let's take a look at this right side. This is an example of not like terms. So these three do not have like terms. This is because there's one x here, right? 2x squared, so there's two x's multiplied together here. There's no exponent 2 on this side, so these two aren't like terms. And in this one, we have x and y. There's not a y anywhere here, so we know that these are not like terms. In this case, the exponents are different and the variables are also different. The coefficients are the same in this case, but coefficients aren't important when we're looking at like terms. Only the variables and their exponents matter. Why do we care about like terms? Because we can often simplify. For example, if we're adding 4x squared y plus x squared y, we can simplify this into 5x squared y because they share the like terms. For example, if you were to add 2x and 2x squared, there's nothing to further simplify because we have different terms. It would just be this. Let's start by adding polynomials. For the addition of polynomials, we have both a horizontal method and a vertical method. Both will give you the same answer, it's just a matter of personal preference. Now, let's start with the horizontal method. Number 1, we're going to write the polynomials next to each other. And number 2, we're going to combine the like terms. So, assuming the problem starts like this, we can start by grouping the like terms. In this case, let's start with y squared. The y squared like term, there's another y squared right here. So we can do 4y squared plus 7y squared. Are there any more y squareds? No. We can move on to the next term. We can do y as the next term. Is there anything with just a y? No. This one is alone. 6y. And lastly, we have constants, aka y to the 0th power. So in here we have 7, and here we have negative 9. We can do 7 plus negative 9. Now we simplify. We have 4y squared plus 7y squared, which gives us 11y squared. And then we have plus 6y plus 6y. And here we have 7 plus negative 9, which is minus 2. Our answer is going to be 11y squared plus 6y minus 2. And we know we're done because we can't further simplify. Y squared is a term, y is a term, and a constant is a term. Because these aren't like terms, we can't further simplify, and we know we're done. Now, let's go over how to add polynomials vertically. Number 1, we're going to arrange the like terms vertically, and number 2, we're going to add each column. So let's start with writing this problem down. It's the same problem as last time, so you'll be able to compare and contrast the methods. In this case, let's write it down. 4y squared plus 6y plus 7. Now we're going to write down this polynomial, but vertically. And we're going to match the like terms. So the 7y squared goes right below the 4y squared. In this case, we have a negative 9 next, so nothing in this y section. You can just leave it blank, or you could write like plus 0 here if you want to mark down the spacing, negative 9. Now we add. So 4y squared plus 7y squared is going to be 11y squared. 6y plus 0 is going to be just 6y. And 7 minus 9 is going to be minus 2. So like last time, we got 11y squared plus 6y minus 2. Now, let's do some practice problems. So we're trying to add these two polynomials. We could do either horizontal or vertical method, but let's do horizontal method for this one. So let's start off trying to combine these like terms into parentheses. So first, if we just go in order, we have p to the fourth power, right? Is there any other p to the fourth power here? No, this one's alone. 14 p to the fourth power. Now let's do p to the second power. P to the second power, anything else? We have one right here. So that is going to be 10 p to the second power plus 3p to the second power. So those two are now handled. What about this one? 8p to the fifth power. P to the fifth power, we have here a 6p to the fifth power. So we know it's going to be 8p to the fifth plus 6p to the fifth. And lastly, we have this p right here, so 4p. And there's nothing else, so it's going to be 4p by itself. Now we can simplify. We get 14p to the fourth plus 10 plus 3p squared, so that's 13p squared. And we have 8 plus 6, so it's going to be 14p to the fifth. And lastly, we have 4p. When we write our final answer, we normally write it with the highest exponent first, going down. So this is correct, but the actual answer you would want to write would be 14p to the fifth, because that has the highest degree, and then plus 14p to the fourth, plus 13p squared, plus 4p. That way the exponents go down, like 5, 4, 2, and then 1. Now let's add using the vertical method. So we have 8k plus 2k squared minus 4 plus negative 6k plus 10 plus 3k squared. Normally, when writing stuff in the vertical method, we tend to write things with the highest exponent first. So in this case, let's write this one first. We'll make it 2k squared plus 8k minus 4. We wrote this expression just with the highest exponent first, going down. So 2k squared plus 8k minus 4. And for this one, we're going to match the like terms now. In this one, to match the k squared term, we have 3k squared. So let's write that down. 3k squared. We have negative 6k, so let's write negative 6k plus 10. Plus 10. So now we can add the like terms. And we get 2k squared plus 3k squared, which is 5k squared. 8k minus 6k, which is 2k. And negative 4 plus 10, which is plus 6. Our final answer is 5k squared plus 2k plus 6. Now, let's get into subtracting polynomials. Just like for addition, we have both the horizontal and the vertical method. Let's start with the horizontal method. Number 1, we write polynomials next to each other. Number 2, we distribute the negative sign. And lastly, we're going to combine like terms. So here we have a problem, 3x cubed plus 6x minus 5 minus this entity x cubed plus 2x minus 1. As you can see, the polynomials are already next to each other, so we can start with distributing the negative sign. So we get 3x cubed plus 6x minus 5. And then now we distribute the negative sign, so it's negative x cubed minus 2x plus 1. Because double negatives make it positive. Now, same as addition, we're going to combine the like terms. So this makes it 3x cubed minus x cubed. That handles this term. And then we have the x terms. So we're going to do plus 6x minus 2x. And we're going to add and make it negative 5 plus 1. And now we can simplify. So this gives us 2x cubed plus 6x minus 2x, which is 4x. And then plus negative 5 plus 1, which is negative 4. And as you can see, Our final answer is already written with the exponent counting down. 3, 1, 0. Our final answer is 2x cubed plus 4x minus 4. Now, let's get into how to subtract polynomials vertically. Number 1, we're going to arrange the like terms vertically. Number 2, we're going to change the sign. And number 3, we're going to evaluate each column. The reason we're going to change the sign is instead of subtracting this entity from this entity, we could change the signs of the second one and do an addition instead. With that, it'll be easier not to mess up signs. For example, instead of subtracting these two, we could do 3x cubed plus 6x minus 5, which is just the normal one. We haven't changed anything yet. Instead, we could add the negative of this one, which becomes negative x to the third power minus 2x plus 1. In this case, as you can see, we've negated this entire thing, but now we can add it, which makes it a little bit less confusing when we add, because you don't have to deal with the signs anymore. So as you can see, these two are the same thing, but it's just written a little bit differently. Now we can do 3x cubed plus 6x minus 5. And now we're just going to add. We're going to add negative x cubed minus 2x plus 1. And then we'll get 2x cubed plus 4x, because 6 minus 2, negative 5 plus 1 minus 4. And we get the same answers before. So we can either subtract these polynomials, or we can add the negative, which makes it easier to solve. Let's practice subtracting polynomials by doing this question. Let's use the horizontal method. So our first step is going to be to distribute this negative sign. So let's start by writing down this expression, y cubed minus 7x 4y to the 5th, minus and minus, so that becomes a plus, so plus 2y cubed. This becomes minus 4x 4y 5 and minus y 6. So let's start with just simplifying and grouping like terms. So let's start with this y third like term. So it's y third plus 2y cubed. Any more? Nope, that's it. So let's do this term next. Plus negative 7x 4y to the 5. We have another one with the like term here. Minus 4x fourth y to the 5th. And then at last we have minus y 6. So let's simplify. So we get 3y cubed minus 11x 4y 5th minus y to the 6th power. Like you might remember, we always want to make the highest degree first. So in this case, we're going to make this negative x 4y 5th minus y to the 6th power plus 3y, because this has a degree of 9, this has a degree of 6, and this has a degree of 3. So negative 11 x4 y5 minus y6 plus 3y to the third power is our final answer. Let's practice one more question with subtraction, and in this case, why don't we use the vertical method? So same as before, we're gonna make this, we're gonna change this sign. So this becomes 2a to the third power minus a squared, just copying it down, plus, then we're gonna distribute minus 5a to the third power minus 3a squared. Now we can add, and we don't have to worry about that negative sign. So this becomes 2a cubed minus a squared, adding minus 5a to the third power minus 3a squared. This becomes negative 3a cubed minus 4a squared. Because 3 is bigger than 2, the exponents, our final answer is already in its correct form. Negative 3a to the third power minus 4a squared. We've reached our final challenge question. Pause and see if you can get the answer before I solve it. Now, let's get started. So, here we're adding these two polynomials and we're subtracting this polynomial. So first, let's simplify, right? We want to distribute this out so we only have to deal with addition. So let's copy these two down first. Negative 5u3 v4 plus 9u squared times v plus 3u3 v4 plus 10. And now we're going to distribute this negative. So negative u4 v4 minus 5, and then plus, because there's two negatives, plus 6u squared v. So now that we've simplified all the negative signs, we can combine like terms. In this case, I'm going to use the horizontal method. So we're just going to group these terms and then add. So let's start with this one right here. We have u3 v4. We have another one right here, u3 v4, and that's it. So it'll be negative 5 u3 v4 plus 3 u3 v4. Okay, and now we have this one, u squared times v. We have another one here, so we have these two. This is going to be plus 9u squared v plus 6u squared v. I think that's it as well. Okay. Then next, we can just add this plus 10, and then we have minus 5. That becomes 10 minus 5. And lastly, we have one more term, which is going to be u4 v4. That's minus u4 v4. Okay, now that we've grouped everything, we can simplify. So this becomes negative 5 plus 3, which is going to be negative 2. So that's negative 2 u3 v4. What about this one? We have 9 plus 6. So that's going to be 15. So 15 u2 times v. And plus 10 minus 5 is plus 5. And we have minus u4 v4. Now we've simplified everything as we can. Now we just want to make sure that the exponents are counting downwards. This has a degree of 7, degree of 3, degree of 0, and degree of 8. This one goes first. This gives us negative u4 v4. That one's accounted for. And then we have this one, which is degree 7, minus 2 u3 v4. And then we have these two left. This one's degree 3. This one's degree 0. So this is going to be 15 u2v. And lastly, we have 5. So negative u4 v4 minus 2 u3 v4 plus 15 u squared times v plus 5 is our final answer. And that's the end of this video. Thank you so much for watching.